Hello everybody, my name is Alireza Hobubaty. I'm from Laval University in Québec, Canada. I'm presenting the first parallel robot with 2 unlimited rotations and grasping capability. As for the background, we'll look into parallel robots with grasping capability and large orientational workspace. 2 of the state-of-the-arts are shown here. The one on the left is from WEN in 2019, which offers 90 degrees range of motion and has 6 degrees of freedom at the end effector, but with no unlimited rotation. The one on the right is from G10 in 2022, with the same range of motion and 6 degrees of freedom at the end effector. It also has 1 unlimited rotation. However, there's no parallel robot with 2 unlimited rotations as of now. This motivated us to come up with a new design that offers 2 unlimited rotations with grasping. We want to use redundancies also to avoid singularities in the workspace, and we put all the motors on the base to have very low inertia. Here we show a demo of the robot. This robot is the first parallel robot with 2 unlimited rotations. We'll look into the kinematic architecture first. As you can see in the picture, the robot consists of 2 identical 4 degree of freedom legs that are connected to the end effector through universal joints. With the kinematic architecture, we can come up with the Jacobian matrices. We have a 6x6 J matrix and a 6x8 K matrix, indicating having 2 kinematic redundancies. These 2 matrices basically map the Cartesian velocities and actuator velocities together. Having the Jacobian matrices, now we can look into singularities. Singularities are basically configurations at which the robot loses some degree of freedom or it has some unwanted motions. When we look into singularities, we can make sure when we are doing unlimited rotations, we have no singular configuration happening. Thanks to the design of the robot, all the singularities are located at the borders of the workspace. For example, when the universal joints are collinear with each other, or if they intersect with the vector from the end effector, we have a singularity that is located at the border. On the bottom left, we show the condition number for a couple of trajectories. For example, doing a square trajectory shown in red, or infinite rotations. We see that the condition number is bounded between 2 limited amounts, meaning there's no singularity happening inside the workspace when we are doing these trajectories. On the bottom right, we see the workspaces. The rotational workspace, as mentioned, has 2 unlimited rotations around the y and z axis, and around the x axis, we have 75 degrees of rotation. The translational workspace is also very large and has no singularity inside. Speaking of the mechanical design, the design has very compact features with modular design. We have 2 identical 4 degree of freedom legs. Each leg consists of U joint, S joint, and UR joints that connect the links together with all the motors on the base. The 2 4 degree of freedom legs are then connected to the gripper with universal joints. The gripper consists of a transmission system. This transmission system gets 2 inputs, 1 from each leg. If the 2 inputs are rotating in the same direction, we have the second unlimited rotation, which is shown in red, and it's called gamma here. And if they are rotating in reverse directions, we have the gripper actuation. Here we demonstrate some motions of the robot. The first unlimited rotation, which is the main contribution of this work. The second unlimited rotation with a view into the transmission system. And the grasping motion with a view into the transmission system. Note that in this case, the inputs to the transmission are in reverse direction. As for the application, we believe underwater exploration is a field that this robot could be used for. This is an emerging field, and it has high cobalt values that are used in lithium battery production, for example, which is very important for the energy sector. The way that this exploration is currently done is by dredging and suctioning the materials that destroys the life at the seafloor. There are some robotic solutions being used, for example, using serial robots, as you can see in the image, which are not effective, since serial robots have high inertia and the motors are exposed to high pressures of water, and there are potential collisions with rocks. This robot, however, with remote manipulation, high dexterity, and low inertia, is a very good candidate for this application. There are also other applications that this robot could be used for example, manufacturing industry, for tasks such as drilling or aerospace manipulation. To summarize, this parallel robot design offers 2 unlimited rotations and has remote grasping, meaning there's no gripper motor, and it has large workspace with no singularity inside. For future work, we want to build a prototype and collect quantitative hardware data. And after, we want to look into the human-robot interaction potential by exploring the back drivability of the motors and looking into rotational smoothness. Thank you for your attention.